10.4 vector operations. Well, for vector operations, some things we've learned is you can take any vector which has a horizontal component and a vertical component, like this right here, and if you do a scalar multiple, you can multiply each component, the horizontal part by the vector and the vertical part by it, and that gives you a new vector that we can work with. When you're adding and subtracting vectors, well, to add, we take the horizontal parts and add them together, and we take, well, the first term of each vector, the horizontal parts and add them together, and then the vertical parts of each vector and add them together. And subtracting, we're going to take the horizontal part of one vector minus the horizontal part plus the vertical, and then the, not plus, and comma, the vertical component minus the second vertical component. It'll make more sense when we actually try those, because I think I kind of stumbled through that. So let's actually look at these and see what we come up with. So let me clear this off real fast. Okay, so on number 1, this is what's called a scalar multiple. We're going to multiply everything in the u vector, the horizontal part and the vertical part, by -3/2. So that would be equal to -3/2 times the horizontal part component, which was -3, and -3/2 times the vertical component, which was 7. And that becomes a new horizontal and vertical component. So -3/2 times -3 is 9/2. And -3/2 times 7 is -21/2. And there's the two parts. If you needed to write it horizontal and vertical, you could also write it as 9/2i minus 21/2j. These are the same thing, so this is perfectly acceptable. This could, depending on how the question asks for it, it's going to be the same answers. They're both horizontal and vertical components. This one is considered linear form. This one's component form. For the next one, let me see. For number 2, we're going to take u plus v. So u is -3 for the horizontal part of u, and then v, the horizontal part was 5, so we're going to add 5 to that. And then for the v, for the vertical component, we're going to take 7 and then add to that the 1, so 7 plus 1. And then that gives us our vector. So that the horizontal part's going to be 2, the vertical part's going to be 8. So when you add the two parts together, you end up with the new horizontal is 2, the new vertical component is 8. For part C, it's pretty much a combination of both of those. We have to take the u and multiply everything through by 3. So that's going to give me 3u is going to be equal to 3 times -3 is -9, and 3 times 7 is 21. And for v, and I'm just going to not worry about the negative yet because we'll subtract them afterwards. So for v is going to be 4 times 5 is 20, and 4 times 1 is 4. And now I'm going to subtract those two values. So if we want to take 3u minus 4v, -9 minus 20, -9 minus 20 is -29. That's the horizontal component. 21 minus 4, that's the vertical component, is 17. So -29 comma 17. For number 2. Number 2 wants magnitudes, and if we look, we want to find the magnitude of v minus u. So treat v minus u like a parenthesis, and let's do what's inside here. So v minus u is going to take 5i minus the -3i, which is going to give you 5 plus 3 is 8i, and then 7j, so it's plus 7j, and we're minusing, no, sorry, wrote that backward. It's j minus 7j. So 1j minus 7j is -6j. So there's the v minus u. There's what that the horizontal vertical components are. We could have done it in component form. It still would have been 8 and -6, which would have been, you would have done 5 minus -3 for the first part, and 1 minus 7 for the second part. So it's still the same thing, but now to get magnitude of a vector is we have to take the Pythagorean theorem where we do change in x squared, so change in the horizontal squared, plus change in the vertical squared, so -6 squared. And 8 squared is 64. Negative 6 squared is 36, and we're taking the square root of that, and 36 and 64 is 100. Square root of 100 is 10. So this gives you 10 for a magnitude. So for the last one, we want magnitude of v minus the magnitude of u. So let's find the magnitude of v. Well, magnitude of v is going to take the square root of 5 squared plus 1 squared. So that is 25 plus 1 inside the square root, which is the square root of 26. The magnitude of u, let's switch colors, hold on. So let me erase and undo that real fast. Magnitude of u is going to be the square root of the horizontal, which is negative 3 squared, plus the vertical, which is 7 squared. And negative 3 squared is 9. 7 squared is 49. 9 plus 49 is 58. 58. Neither one of those can be simplified because that's 2 times 13. That's 2 times 39. Nope, so everything's prime. So v minus u, or the magnitude of v minus the magnitude of u, is going to be the first answer, 26, minus the second answer, 58. And nothing else we can do to that. And that is everything you need in order to be able to pass the assignment 10.4. Good luck to you.